is I realized there's a big void in the education around this technology. And I didn't think that was right. I thought that everyone had the right to access these sort of processes if they were interested. So I decided to start making videos in my spare time, in my bedroom, and I uploaded them onto YouTube. And over time, those videos became popular. People requested more videos, and it got to the point where I was spending all my time making videos. When I got home, I was working till midnight doing this sort of second job. To the point where I thought, okay, I've got enough interest, I'll just jump into, go away, Apple. We don't want you here. I thought I'd just jump into doing it as a job. So I work on YouTube as a full-time job talking about 3D printing. And our mantra is empowering creativity through technology. So a little bit about the channel. We have just over 35,000 subscribers now, and it's growing all the time. There are over 3 million views, over 200 videos. And we talk about 3D printing as a technology, we talk about 3D printers, and we review machines, so we provide unbiased feedback on machines people might be interested in purchasing. And we do tutorials, so if you're interested in learning how to model things, you can go onto our channel. Anywhere in the world, we have subscribers from every country, and you can learn about it. So a little bit about myself. So my name is Angus, and I studied industrial design at UTS, which is a fantastic university just down the road. I pretty much went there because they had a fantastic workshop, and I like to tinker and tear things apart. So I'd go there during the uni breaks and just use their workshop. And the degree was kind of a sideline to that. But while I was there, I learned how to 3D model using software. I learned how to use 3D printers. But at the time, 3D printers were very restricted. So to give you a bit of background, the machines we used at the uni were known as Stratasys machines. They were Stratasys Dimension SSTs. They were roughly the size of a fridge. They cost about $80,000 each. And as a student, we were given basically the cost of materials to print, so they weren't charging us any excess on that. And a print, maybe this size, would cost us about $500. So, but while I was finishing up my 4th year, or starting my 4th year, I thought, okay, I'm keeping an eye on the cost of 3D printers, and they're starting to drop. They were still pretty expensive, but a few key patents had expired, and a few Chinese companies were capitalizing on that. So I thought, okay, I'm going to invest in a 3D printer, which cost me about $1,500 at the start of the year. By the end of the first semester, it had paid itself off, instead of using their machines. So that was just an eye-opener for me. So at UTS, during industrial design, you do a research project, and then you do an actual design, and you design a product around that research. So I decided to look into this phenomenon of 3D printers becoming cheaper and how they could be incorporated into a domestic environment. And that was a really exciting time for me, because during that time, a couple of years ago, sort of 2013 or so, the machines were changing, getting cheaper and more interesting and more developed so fast that my thesis was becoming out of date as I was writing it. So a good example is there's technology called SLA from the early 1980s. It's a liquid resin-based system, very well developed, but was very expensive. And I was saying in my research, okay, it's one of the highest resolution processors you can use, but it's a bit too messy, still too expensive for the domestic market. A week later, a machine launched on Kickstarter, which is a crowdfunding campaign site, called the Form 1. This was an SLA printer, desktop size, $2,000. So like 1/100th of the cost of what other machines were being used in industry. So that whole paragraph was out. And the whole thing would be completely out of date by now. That's how fast it was changing. So by the time I got to the second semester, I was like, well, I'm not going to make another 3D printer because every man and their dog's making 3D printers now for the domestic market. How can I take this idea and take it to another field? So I can't remember why I exactly did it, but I decided to design a cake icing 3D printer because of my interest in baking and also my interest in manufacturing technologies. And it was the same idea, making 3D objects, but it was using cake icing instead of plastic. And I bit off way more than I could chew. I was the only person in my entire class to make a functional prototype. It was also made from 3D printed parts, so you couldn't eat anything it made because it was horribly contaminated. And my tutor said I was mad, and they would have recommended 3 engineers and 2 industrial designers to do that kind of project. But it was good, and I got a good mark, so I was happy with that. So by the time I was done with that, I, as I said, went into 3D printing as a job in a studio, but then decided that I was more suited to the education side of things, and that's when I moved into YouTube as a job. So what is 3D printing? As I said, it's actually been around since the early 1980s, but it's still been taken until now essentially to become accessible. But there's many different technologies, and they all work the same way. 3D printing is an additive process. It takes a material, it could be a molten plastic which solidifies as it cools, it could be a liquid resin, it could be a powder, but it lays it down layer by layer. So 3D printing builds up parts layer by layer, instead of traditional subtractive machining or subtractive manufacturing, where it takes away material. So imagine a sculptor or carver might have a block of wood, and they'll chip away at that wood to make a sculpture, so you have all this waste material. 3D printing is the opposite. You start with a raw material, and then you build up your part with very minimal waste, which is fantastic. And that also means you have very low geometry limits. So, as a great example of this, this is completely 3D printed in one piece. All the links are joined, and that's only possible because it's printed layer by layer. All the links form at once. Which means it's fantastic for the fashion industry, and it's fantastic for the art industry as well, because they can realize ideas which weren't previously manufacturable or without great difficulty. And it's also great for this idea called mass customization. So mass customization is the idea we have a sort of default stock file, and it's modified for the individual. So a great example would be shoes, or maybe even shoes with built-in orthotics. So at the moment, you go to the shop, you buy size 8, size 9, size 10 shoes. If you're between sizes, or your feet are slightly different, tough luck. They don't fit very well. The idea of mass customization, you have a shoe template, and then you have size Angus. And then that shoe is made using rapid manufacturing or 3D printing technology. And that's already starting to happen. As I said, orthotics and also Invisalign, which are sort of custom-made teeth whiteners, they're already 3D printed and used, which is fantastic. And you're going to see that more and more as it becomes more accessible. There is a few limitations of 3D printing. Currently, it does take a long time. For example, this took about 14 hours. So it's not fast, but if you want one of something, then it's a lot more accessible than going down like an injection molding mouse or something, which would be far more expensive. And also the materials are kind of not as strong as some other processes, but that is changing rapidly as well. So into uses of 3D printing. As I said, it's been around for a while, and traditionally it's been used for prototyping in the engineering fields. That's why I used it in industrial design. We made prototypes, which is practical, but not that exciting. And the thing about 3D printing now is it's becoming cheaper and therefore more accessible, so other fields are taking advantage of it. So a great example of that, as I said, would be the jewelry and fashion industry. So the fashion industry is going nuts with 3D printing because they can take algorithms or complicated designs, which would have been hard to manufacture before, then they can just get them printed, sent back to them, and then they've got a fantastic one-off piece they can sell for a lot of money, so it makes a lot of sense to them. Also jewelry, there's machines that can print in a sort of wax-like material that can be burnt away for investment casting. So most custom rings these days use 3D printing. They'll be designed by the designer in 3D modeling, made in a wax-like material, and then cast into platinum, silver, gold, whatever you like. And it's fantastic and makes a lot of sense to the industry because it's fast and it's actually quite affordable. You can get a ring made for a few $100 depending on the metal you go with. And then there's the medical field. So if I had cash to invest, medical field 3D printing, 100%. It is going to change the world. And that's because, as I said, every 3D print is a unique one-off object. So if you have an implant or a custom component for a patient, it can be made specifically for them. And then it's 3D printed and then implanted, or in some cases, they're actually using them for surgical studies before they go into the operation. And you can just use low-cost machines for that, because it doesn't need to be safe for implant, which is really, really cool, and that's changing the medical field, even in third world countries currently. And in terms of materials that are 3D printed to be implanted, there is metal 3D printing as well, which I'm going to talk about in a little bit, which is really exciting. And that's sort of the next step in terms of taking 3D printing that's sort of nice, but not that practical, to actual practical real use applications. And one of my favorites in the middle there is you can 3D print a 3D printer. So basically, you can download 3D files and you can print them, and then you can make your own 3D printer. The basis of that is an open source project called the RepRap project. So there's many machines based around that, and it's been evolving since 2007. And yeah, anyone, if you've got a bit of interest, a bit of a hobbyist tinkering background, you can just print machines, which is fantastic. I love it. And then something that's kind of a little bit in the future is the 3D printing of buildings and that sort of thing. So, I mean, at the moment, there's a few different takes on it. What you can see in the bottom right corner there is they're building a room with these blocks that they've 3D printed out of like a sand and binding material. But they've actually gotten concrete cranes, essentially, which are computer controlled, to print out temporary structures. Obviously, sort of the foundations and that sort of thing needs to be finalized. But if you're printing a quick sort of solution for disaster relief areas, that's the sort of idea they're going for. And NASA's even actively looking into the idea of using that sort of technology on the moon to use the actual materials they can get there and a binder or something like that to make structures on the moon. Which sounds nuts, but who knows? All of this sounded crazy a few years ago, so we'll see how it goes. So as I said, with 3D printing, you need a 3D file. And to create that 3D file, there's many different ways. And like 3D printers, this is changing all the time. So what I studied was SolidWorks at university. I spent 4 years learning SolidWorks, and I still don't know how to use it properly. It's like one of those programs that just can do almost everything if you know how to use those tools. So it's not really great for a primary school kid, and it's certainly not great to pick up if you just want to use 3D printing as a hobbyist level, on a hobbyist level. So there's other programs like ASCCAau, which is completely browser-based. It's based in the cloud, so you don't even download it. It's fast, and it's designed for basically kids. So I've seen I've seen 6-year-olds, not year 6, 6-year-olds pick up ASCCAau within a couple of hours and design all things from spaceships to their own little favorite characters to robots. And then ASCCAau can export to a file format that 3D printers understand. They can go do it. So I actually used to run a 3D printing club at a school here in the city, which is International Grammar School, for year 7 kids. And it got to the point where they were just designing pretty much anything they wanted. And it was actually interesting because it was half girls and half boys. And the boys were designing robots and guns and that sort of thing. But the girls were designing My Little Pony characters and My Little Pony accessories and cookie cutters. Why not? You can pretty much print anything you like. And that's what I really like, is the idea of 3D printing, that it empowers that creativity. They're having a great time. And then there's other programs like Blender as well, which is still advanced, but that's completely free and open source software. So it's becoming more and more accessible to get into 3D design and 3D printing. Then there's 3D scanning. So I'm not going to lie, 3D scanning is still lagging behind 3D printing a fair amount, but it's becoming more and more accessible with different technologies becoming available. 3D scanning, the idea of that is you take a physical object and you then digitize it. You're not starting in digital, you're actually taking something that's real and physical. And there was a craze maybe 2 or so years ago on mini-me's. Has anyone heard about mini-me's? Yeah. So the idea essentially is you get yourself scanned and then you get a miniature version of yourself printed, like you can see there on the right. I always sort of said that this was a bit of a gimmick, and a lot of companies that started this a few years ago have since gone broke. I always figured that, we're always judging ourselves in photos, so why would you want a 3D mini version of yourself? I don't know. But I do like the idea of that if it was sort of being used in maybe like a bridal room on top of a cake or something, but still very niche. But 3D scanning, as I said, is still a bit difficult, but there is a few apps worth looking at if you are keen to try it out. There's a program called 123D Catch, which you can run on your phone, and it works with a technology called photogrammetry, where you take lots of photos, and the software will stitch those photos into a 3D model. So it's not very accurate, but it is free, and it's very interesting to see if you want to dabble with 3D scanning without having to spend lots of money. So let's talk briefly on some different technologies. I'm not going to go into depth because there's literally hundreds, but the one that you probably would care about the most if you're looking at getting 3D printing on a low level is FDM, Fused Deposition Modeling. So think of FDM as maybe a computer-controlled hot glue gun. It takes a filament of plastic, which I should have brought some with me, but it's like a filament of plastic, it's like whipper snipper, plastic wire, and it melts it out on a hot end. And it does that layer by layer, line by line. And when some of you come look at these later, you can see the layers quite clearly. It's not the highest definition process, but it's definitely the cheapest. The filament's about $50 a kilo or so, and it's definitely the easiest to get into. So machines that print this sort of stuff are coming down all the time. You can get them for now about $300 for a 3D printer now that will do this sort of technology. Then there's SLS. So if the FDM would be the machine technology you use at home, SLS would be the one that Officeworks would have. These machines are still very large, still very expensive. It stands for Selective Laser Sintering, and it's a powder system. So the cool thing about SLS is it's a nylon powder, and you don't need any sort of supports or there's no limitations at all for your printing material. With the FDM, there's still gravity that you're fighting as the part's being produced because it's in air. Whereas with SLS, it's a powder, and the powder's sintered in place. So when this print's done, you pull it out of the loose powder that you didn't sinter. So it's hard to describe, but essentially that's how you can do this sort of chain round. This is what the fashion industry is going crazy about. Also, being nylon, it does tie-dye and take clothing dyes very readily. So you can actually produce amazing coloured results, which you can see there on the left. That's all just dyed with grit clothing dye from Spotlight. It works quite well. Surprisingly well, actually. But most exciting for me would be SLM, which is Selective Laser Melting. And the reason that's so exciting is it's a metal 3D printing process. So what I have here, which I definitely show somebody who's interested later on, is a stainless steel 3D print. So this is produced with a stainless steel powder, similar to SLS, but it's metal powder, and it is selectively melted with a laser. Layer by layer still, but this part is probably it's 99.7% dense, which is almost as good as a forged or cast piece. And essentially, this can be used in real-life applications. So Boeing and NASA are heavily investing in 3D printing of metals in aircraft-grade materials like Iconels and aluminiums and stainless steel, even maraging steels, and they're using them actively in actual use cases, which is fantastic because you can do sort of these lattice structures and things you couldn't do in any other process. And actually, just a side note, this one, I visited a company in China. So this is a Chinese SLM machine. So these Chinese companies are now taking these ideas and they're building them cheaper. So although this machine's still the size of a room, it's about a quarter of the cost of what was there previously. So it's a really exciting time. And as I said, there's hundreds of different processes. Don't worry about the acronyms. So just a little touching on what we do. So as I said, we are a YouTube channel now. So what we do is we produce YouTube reviews and YouTube tutorials, but we also produce projects. So this is a fantastic example. I call this a torture test. It's a difficult 3D print to produce. And because we have so many subscribers, I designed this file and said, you know, hey guys, I challenge you to try and print this. And I put the idea out to the community. And you can see just there on the top right, that's someone else on YouTube who took the idea and they made a giant one. So that's Joel Telling of 3D Printing Nerd, and he's one of my buddies, and he is in America, and he has very large 3D printers. So he took this idea and giant-sized it. And that's what I love to see. I love to see the collaboration and sort of sharing of ideas in this space. And it's still very open and very friendly, which I like to see. You know, a lot of communities tend to become quite closed as to what they're doing behind the scenes. 3D printing is not like that. It's very open. So when I put this idea out there, a lot of people took it and then did their own thing. And it's funny because I actually sold this file for $5, which is not much. But it's a digital file for $5. And some people said, I'm not going to pay that. I'm going to model it myself. And they thought I'd be annoyed about it. And I was like, no, I got you to 3D model something. That's what I'm here for. So yeah, I find that really, really exciting. Yeah, so that's going to about do it, but if there's any questions, I'd love to take them.